Hello guys, Kushti is here, and today I'm going to explain you a simplest DEX contract. So a contract which is about exchanging ERGs for tokens on the Ergo blockchain. Right, and this is the simplest contract of atomic swap kind, so it doesn't have partial filling and other properties which are doing contracts much more complex. Right, and let's go to the example which is already published in the ErgoScript by example repository. And this contract is available in the Ergo Playground, and the Ergo Playground is an interactive tool in the browser. So this is the browser, you see, and you can run contracts on top of a simulated blockchain, and you can modify the contracts, and you can thus make your own experiments with browser just. All right, and now a little bit about contracts in Ergo. Right, so in Ergo, unlike Ethereum, for example, we don't have a notion of smart contract as a single piece of code deployed at some address, and then you can send signals to this single entity, right, and getting some result. So in Ergo, we have a notion of contractual money, right, and this is about Bitcoin paradigm improved to the DeFi extreme, right, and basically contracts in Ergo are attached to one-time coins or one-time banknotes. So picture it's about this. So I have some digital banknote on the Ergo blockchain. So this is one-time banknote. So any transaction which is spending it, destroying it totally, and creating a new banknote, right? And this banknote is associated with some spending contract, right? And so if I want to do an exchange on the Ergo blockchain, so what is this contract could be about? So I'm telling in my contract bound to this banknote something like I'm allowing to spend this one-time banknote. If you create a new banknote with some custom tokens, right, for example, and there are no less than 50 tokens, right, in a box you create for me. And also this newly created banknote, or UTXO in the Bitcoin jargon, we also calling it box in the Ergo community, this one-time entity, because, well, in addition to just nominal and contract, there is also possibility to carry on arbitrary data, right, inside a box. Okay, so I'm telling that this newly creating box for me must be associated with my public key, right? Okay, and in the same way we are doing sell order, right? So sell order is attached to one-time box, right, with custom tokens. And well, the contract is saying that well, okay, you can take this box, right, you can spend it, but you need to create a new box for me which contains at least for example 100 ERGs. Okay, and so let's go now straight to our example. So we have buyer Bob and seller Alice. Right, we have a token which is called TKN. Right, so Alice has 60 TKN tokens, and Bob is willing to buy them for 100 ERGs. Right, and Bob's contract is doing more or less the same as I already said. So in addition to the matching condition, so there is also a refund condition, right? So Bob can withdraw at any moment. And the matching condition is saying, that's a newly created one-time banknote or box for Bob must contain at least 60 TKN tokens. Right, and this newly created box must be associated with Bob's public key, right? And there is also another condition a little bit involved, so you can read about this in the comments or white paper. But simply, for safety, we require a newly created box to explicitly refer to the box being spent. Right, this is done to avoid scenarios when there are two buy orders from the Bob and they can be matched by just one sell order. Right. So it's simply about that, and you can read and think about details while reading white paper or comments in the ErgoScript by example repository. Alright, so we create buy order transaction. Right, and Bob is signing this transaction and posting it on the blockchain. Alright, so now Alice's contract and her contract is basically the same, with the only difference that her output is now number 1, right? So Bob's was number 0. And Alice is providing tokens, right? For contract, it's implicit. And Alice is requiring for 100 ERGs to be appeared in her output box. Okay, and for sure, this 100 ERGs must be associated with her public key, so pretty much the same. And she is creating her sell order, she's sending it to the blockchain. So now we have buy and sell order posted on the blockchain. Alright, so now we are going to create a matching transaction. Also we can test, and we need to test, right, to be sure about our contracts, also the refund path, right? And to test in this example, simply we are flipping a random coin, right? And if the coin is saying do refund, then refund is done. For simplicity's sake, in our example it's done for Bob only, right? Otherwise we are doing a matching transaction, right? So matching transaction is consuming sell order and buy order in any order, and it is creating new boxes. So first one with index number 0 for Bob, right, and second one with index number 1 for Alice, right, and Bob's output is containing 60 token tokens, right, and Alice is containing 100 ergs, right. So well, then this constructed unsigned transaction is to be signed, and well, actually anyone can sign this transaction because there are no any secrets involved. Right now, so in our example we are signing it with Bob's wallet, but well, actually it can be any wallet. So we can, for example, construct a new random wallet and sign this matching transaction. Alright, then the signed transaction is sent to the blockchain, right, the simulated blockchain, and yeah, let's see outputs now, output log. So well, initially Bob had 200 ergs, well, 200.1. Right, and Alice had 60 token tokens and a little bit of ergs to pay the fees. Okay, yeah, so she had 2 ergs. Alright, and at the end, so Bob now has 60 token tokens and yeah, also a bit more than 100 ergs, right, and Alice now has 100 ergs asked, right, and yeah, no tokens she has anymore. Alright, and now about efficiency and blockchain bloat, some note. So we have 3 transactions needed in our example. So buy order transaction, sell order transaction, and then the matching transaction. But in reality, there is no need to post buy and sell order transactions immediately on the blockchain. So those orders can be posted to some matching servers. So it can be some trusted centralized matching service, or it can be, for example, a P2P network doing matching. And so only if orders can be matched, then the matcher is creating also matching transaction and sending all 3 transactions on the blockchain. And thus we can avoid on-chain orders which are costly and also creating a lot of blockchain bloat, for example for Ethereum order book based DEXs. Right, so in our case, well, when we are using the matcher service, so only when matching happens, then well, order transactions to be posted on the blockchain. Okay, and this is again the simplest example, and it can be enhanced with different additional requirements, additional properties, and well, I'm going to make some new examples and publish them soon. So well, the vault of DEXs on top of Ergo is going to be uncovered, going to be implemented. So stay tuned, and we'll have more examples soon. Have a good day. Bye.